Welcome back to the second session of React with Teacher Lei. So today we're going to be going over basically the full React lifecycle and some TypeScript. And in the meantime, obviously going over JavaScript because JavaScript is the basic backbone of TypeScript. So let's get started. Quick thing about what we learned last week was we learned something called TSX, right? Which is the same thing as JSX, which is TypeScript expression. And it's basically React abstracted away, right? So you can have something that looks like HTML, CSS, and then you can put some JavaScript code, just like that. And that's basically what we learned last week, besides all of the development stuff and like the environment that we are going to be working in, which is pretty interesting if you want to take a look at that. So I'm just going to get started a little more. I briefly mentioned what TypeScript was previously, but just to reiterate, it's an open source language built on top of JavaScript. And it is essentially just JavaScript with types. So because of that, TypeScript is a superset of JavaScript, as you can see here, which means that all JavaScript is valid TypeScript, but not all TypeScript is valid JavaScript, right? So keep that in mind because we're going to be talking about JavaScript first of all, and then I will add in typing, since TypeScript is simply JavaScript with typing. The reason why we're doing TypeScript, as I stated previously, is because it's strongly typed, there's just less bugs, and it just speeds up development cycle. So yeah, I'm just gonna get started then. In JavaScript, right? How you would create a function, there are like two main ways to create functions. One is by, let's get into a file. That was the file from last week. So one way you can do it is you can do something like function app, parentheses, and then bracket, right? And then you go return. This is the same thing in like Java, C++, Java, etc., etc. One other way you can create functions that we will mainly use is something that looks like this. So this is called an arrow function. And honestly, you can just memorize the syntax, but yeah, okay. But basically, it's just it's almost like this variable is being set to this function, right? So you would call this function by doing something like JSX, you would do curly brackets to embed JavaScript code, and then you would call the method, right? And just like before, you do the method name and then parentheses. Of course, you can also add in variables, so like maybe it's like name, right? And you would do something like plus name, right? So you can have variables as well and parameters as well. Right? You can do something like that. That's how you would create a function. You might ask why you would do this kind of arrow functions over this type of functions, because this is probably more intuitive to you, right? There's actually a little bit of reading that you could do if you're interested in that, but basically it has to do with like the binding for like classes a bit. It's a little complex, so I'm just not going to go over it too much, but there are like reasons why there's a difference. But just as a general rule of thumb, you generally use like these arrow brackets when it's within anything else, right? So like over here, you can do const, blah, blah, blah. And you would generally do function if it's not within anything else. So like for instance, this one should be a function. But honestly, if you forget, just do an arrow function. It's not a big deal. But if you're interested, come here and take a look here. Why we're doing arrow functions over normal functions. But I'm just going to continue. Just to continue, like obviously there's primitives in JavaScript, right? So there's like string, boolean, number, things like that. I can't really recall all of them. You get the idea. It's the same thing in all the other languages. But there are, of course, arrays and objects, right? So arrays are same thing as like vectors in C++. So it's just some list of items. So let's just say like string, meow, etc. Stuff like that, right? So that's what an array is. It's just a list of items. What an object is it's kind of like a map. Don't think of it as a map, right? It just has a structure that looks similar to a map. So there's some key and some value, if you know what a map is. If you don't know what a map is, perfect, that's totally good. Basically what it is you see this? If you know what an object is in like for C++ and Java and object-oriented programming, there's some variable, right? And you set the variable to some value, right? So that's why you would do something like that. Right now in this object, this cat owner's object, there are 3 member variables, owl, melm, and gude. And they all have values to the variables, right? So that's basically what a object is. It's just an item with variables inside, right? Yeah, that's that. I haven't gotten in TypeScript yet, right? It's kind of this part, but just pretend that I did that. That was what JavaScript looked like. It's getting a little angry, but just because I'm using some strict typing in TypeScript, which is not a big deal. Don't worry about it too much. So I'm going to continue. There's 3 main things in JavaScript. So there's const, let, and bar. Const val is equal to something. Let bar is equal to let. Something else is equal to something else. And then bar blank is equal to something else. Right? So basically what const is that like you can't reset it to something else. So if you do something like val is equal to blah blah, you're gonna get angry because it's a const, so you cannot assign it, right? Const is block scope, right? Which means that within a single like block, say I have like here, and I have like if something, well, if it's true, I'll just do it. And then something else. If I put a const val in here, let's see it. And we can't actually access val out here, like it doesn't exist. And this is gonna like throw an error when we actually run it because it is block scoped and not function scoped, which means that like it just only exists in here, right? Same thing with let. It's also block scoped, where that like if we do let val equal to that in here, this will not work when we run it. But what would work other than const is that you can actually set it equal to something else, right? This would actually work. As you can see, it's not getting 8. Okay, so that's const and let. One last thing you'll hear about is var. Var is generally something that you would try to avoid using. Var is something that's function scoped. So if we did var val is equal to that, these 2 lines would actually work because var you can reassign, but because it is function scoped, val actually exists in this entire function, right? So that means that this line 10 will actually compile properly. So yeah, that's the difference between let, var, and const. Generally try to use let and const because there's not a lot of use cases for function scope. It just is more prone to error, right? If you want to take a look at like what like an example, you can take a look at this and see what error would exist, right? Cool. So we talk a lot about like a lot of like basic JavaScript. I'm gonna go over a little bit more of like more React specific, I guess, syntax that you might need. So there's a thing called spread operator, right? And what a spread operator is it opens up an array or an object to add more things in, right? This is super useful for React. Like this is something you definitely need, unless you want to do it manually, which is really annoying. So this is really important for React. So basically, right, if you have an array like this, let's have an array. Let's make an array. make it right. Let's get it right here because I'm too lazy to write it myself. So if you want to like add another item to this, you can do something like cats dot like push, and you can add another item at the end of the array, right? But in React, like you actually can't modify the current variable. So what's really important is being able to create a completely new instance, like basically a clone, right? But show that it's something completely different. So what you would do is you would do const cats like do or whatever, and like you can just spread the current item, spread the current array with a dot dot dot, and you can do dot 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 cats. Cats2 is currently now a duplicate of cats. And then if you add, basically it's just what this dot 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 cats is it's a duplicate of this part. So if we do dot 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 cats and we add another item, let me think of something cooler. And now you would have cats, which is equivalent to all of this, right? And then with the appended at the end because we have done that here. So that's what a spread operator is. Just to reiterate, it's a 3 dots before the same item, right? And honestly, yeah, here you go. It's the same with objects as well. So for objects, if you want to add another item to it, so let's just say we have const cat under 2. And what you would do is you would also do like squiggly brackets, and then you would do dot 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 cat owner, and then you add another item. So basically, when you do dot 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 cat owner, it's the same thing as with the array. You just grab everything inside, and it will like just put it over there, right? And then now we can add something else. So let's just say like let's add like and then we can make it so that you have a cat named Sha, because French. Yeah, so that's what spread operator is, right? Just to reiterate, it's just dot 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 and then the thing that we want to spread. Cool. So I'm going to continue a little more. I'm going to continue and switch gears and talk about TypeScript a bit. So just typing things in general, right? So just now, like, you know, when I caps dot, it showed me all of the methods that are available and what it takes in and like stuff like that, right? That's because it knows that cats is a string array from what we've told it, right? But if we add something else like 3, what will happen is that it's going to be either a string or a number array, right? So what we can do to make it so that like maybe like we don't want anyone to like do this, we can make it so that we can type it equal to some string array. How you would do that to type something is you do colon and then the item you want it to be like. So string array is what we would want, right? And right now it would highlight 3 because number is not assignable to string, so it would catch that error, right? So that's how you type. A few things you can type. Like I said before, string, Boolean number, and array. So string, Boolean number, you just do Boolean, you just do number, etc., etc. But for an object, it might be a little more difficult to type, right? Because how do you even type this stuff? If you hover over it, it's like, oh, like I don't really know what's going on, right? So what you can, this is a little more complex. I'm not actually going to go over it. But if you want to type an object, you can look it up. But also another thing you can do is you can do something like all, and then string array, and then now has to be some string array, and then good has to be some string array. Right, like that, right? And you do the squiggly brackets because it's an object, right? So this is an example of how to type things. And if you want to type a method, it's the same thing as well, right? We just did it earlier with meow equals to blank. So you can type the parameter and you can also type the output, right? we know it's a string, and that would work properly. But actually, we don't really need to type the output, because if you hover over it, it's going to imply that it's a string, right? Just because we know that meow is a string as well. So TypeScript helps you also interpret things by itself. So that's TypeScript. So there's a little bit more about specifics of TypeScript, because there's more specifics. Let's just say that we want it so that we had some type cats, cat list, and that is equal to string array, right? So what we can do is now we can replace this stuff with cat list, because it is now currently typed as now these are all just typed as this cat list, which is a string array. So that's what a type is. It's just literally just a type, right? Something else that is important is something called interface. And generally, you would use interfaces more for objects that you want to type, right? So type you might want to do for function parameters. Not really this function parameters here. While interface you would do for almost everything else, right? So I'll go over it a little more. But basically, what an interface looks like is it's kind of like the skeleton of an object. So for instance, you would do something like interface pet, right, is equal to, and then maybe the pet has some name, has some owner, has some age, right? So now we can make it so that every single one of these items is a pet instead. So if we do that, right, it's going to get angry at everything, because it's expecting these to be objects now. Objects with name, owner, and age, right? So you would have to do something actually, I'm not going to do that. This might be a little confusing. So if I wanted to make it so that some method, let's just say const pet cleaner, some pet with some type pet, right? Then you would do something like, oh, sorry, this is not how you do a is equal to. So what you would do is you would do something like console.log pet.name. You see how it has all of these automatically? So you can do name plus space plus pet.age is age, something like that, right? So we can print that out. And now if we pass it in pet printer, we pass it a string, right? It's going to get really angry because it's not a pet type. This is a string type. It's not a pet type. And if you look at it here, it says that it's not assignable to the type pet, right? Which is as expected. So if we pass in something of the same shape as this, so name, some string, owner, me, age 4, right? So now it won't get angry, and when I run this, it will print Pickles is age 4, right? So that's how you would type with interface and type. And just to reiterate, generally you want to do interfaces with object types. So, and also anything types generally you would do for functions. You use basically interface for anything else. So yeah, that's the main things of TypeScript. I'm going to continue on to some more React specific information. It's not really React specific, but it's the general trend nowadays, which is functional programming, right? So functional programming will look something like this, where, before, you would do for loops, where you do for in I is equal to 0, I is less than 3, or 4, whatever. I plus plus, not int. Then you do something, right? If you do it like this, or like if you do like, oh, like until that's not length, you do something, right? Let's just say that you do print log. Okay, you just print it out, okay? Yeah, you can do that, but it's kind of much more recommended nowadays to do like functional programming. What that means is it's basically combining into one line, right? So I'm just gonna copy and paste it because it's just faster. Basically, look here. If you look here, it says cats. For each of the cats, you do something, right? So for each of the cat, given the cat, you want to console.log the cat, right? The cat itself. So I'm not going to do all that. Cool. So these two are actually equivalent. And if you look here, it looks really similar to the arrow function that we've done previously, right? So the arrow function that we've done previously looks like that, right? It's basically, you can also, another quick thing aside, that if you want a shortcut, is you can, if there's only one line, you can make it into one line. So it would look like that. Yeah, these two are basically the same. And basically what's happening is for each item in cats, it does a thing on cat, on each of the cat, right? And cancel log, basically. So yeah, that's what for each does. The next thing is map, right? So what map is it's basically just for each, but let's just say it, instead of console logging, we want to return each of these values, right? So, and then compile it into one array. So what you would do is you would do map plus and hi, right? So now if we look at the value for this const, that's say hi. If you look here, now it's just going to be a string array that is basically just going to consist of these elements. It'll be pickles says hi, and then it's going to be Oscar says hi, and so like, right? Basically just append says hi to every single element into that says hi. That's what map is. I'm not really going to go into reduce, but basically reduce is it accumulates on each value and it like adds from previous, right? So for instance, if you have like a number array or this array and you do reduce, then let me just show it actually since we have some time. This is going to be previous value, and then there's going to be that, and then if we do something like prev, and then prev plus space plus that, and it's just going to return a string, which is concatenated with concatenate together with the space of the separator, right? There's just going to be a string, and that's what reduces. Yeah, there's actually like quite a few other commands like find, filter, and just a lot of other things. And you can honestly just look through it, see what you like, and take it from there. These are the most common ones that are pretty important to know. So you can just look at like all these different things that we have, right? I'm not gonna go over all of them because that's not what this is for. Yeah. Cool. You've actually learned basically all of the JavaScript and TypeScript we need for React, right? So we're going to continue on and get into React a bit. And map is actually super duper useful in React, right? Map and that spread operator thing that we learned. those two are like main components of React that we will use a ton. So let's just say like in the app, I'm just gonna start using my type of hot sec. Okay. CB, what is this? React. So if we look, we'll see that we can do some stuff, right? Let's just say we have an array, right? Which we have an array. I'm gonna pull these two up here, cat and cat owner, so that I can see a little better. And then let's make it so that like every cat, some cat is gonna do something, right? What do we want to return? Sorry, not in there. Let's just say that we want to return that Pickles is the cat. You do squiggly bracket because it is JavaScript inside of this thing. This thing is TypeScript expression. So cat is a meow, right? And if we start it up, still loading. You'll see that like it will make every element into this, which is super nice. It's a little angry. Why is that? I do not know. Oh, because it shouldn't have this. It should be that. And I'm going to have a squiggly bracket there. There we go. Okay, let's try it out. And you'll see that each of these cats are going to be printed out. This is basically the power of React, right? So that now you don't have to like, remember like we went to YouTube or something and like checked out that like every single thing was pretty similar? It'd be really stupid to do that in HTML, CSS, right? So this is a really easy way to like, in React, to like just make mass produce things, right? And basically if we change anything inside of cats, then it will automatically reflect inside and add in a new line, right? That's some pretty useful stuff for a map, right? But if we look at the council log right now, we'll see that it'll have this warning. Each child in this list should have a unique key prop, right? So what's going on here is that like each of these elements are different, right? React, how it works, how it knows what to re-render, is it doesn't know like which element has been removed. So like let's just say remove this, right? It doesn't know what's been removed, so it's gonna have to re-render and recreate every single one of these. And that's not very optimized, right? So this is a thing called key list, where you can specify the key of this element. It should be something that is unique. And basically like, and the key changes, it knows that it needs to re-render. But like, let's just say we remove Oscar, then it will know not to re-render Pickles and Mittens and Boo because it knows that's the same as before. So that's how like React like reconciles. If you're interested in how like React knows what to re-render, you can look into a little bit about like React reconciliation. And this is a pretty interesting like read if you're interested in that. But I'm just gonna continue. So that's what listing keys are. So if we save now, we will see that this issue will actually go away. So let me reload to show you. And as you can see here, it's no longer getting angry about the key because we have set it equal. So we've done a ton, right? We've done a lot of this things. Okay, two last things we need to cover before we are basically done with overview of React, okay? Two things are state and prop. And we're gonna, if you've ever heard of like class-based React versus like functional React, I'll go over a little bit as to like what the difference is and why we're choosing functional React. But for now, just for now, if you don't know what that is, totally good. We're gonna learn about state and props. And these are the backbone of React. So what state is it's how React knows to re-render things, right? So when the state changes, React's like, oh, my state has changed. Time to see if I'm supposed to re-render things. So basically that's how it works, right? So if you look in this example, number is a state and set number is the setter for the state. And whenever number changes, it will re-render this part, and see if anything else needs to be changed, right? That has number. The reason why there's a setter is because React uses the setter to know when it has changed. So if you just like set number, if you do number is equal to 3, just all of a sudden, React might not know to re-render this part. And it might stay at like 2, what it was at before, right? Which is not what we want. So that's why we have to use a set number. It's just part of the reconciliation if you're interested in reading that. But basically, you have to use a setter for React state. That's how React knows what to re-render, right? It's like the key thing. Let's just do a quick example of this. I know this is a little messy by now, but that's okay, right? Yeah, I'm going to just comment this out. Oh no, I can't. I might not be able to. I'll just like pretend that's not there. Okay, cool. Okay, so I'm just gonna copy and paste this. Let's just make it so that it's like num-pets. How many times it has a cat and pet, right? Set num-pets. Cool. Use state. So it doesn't know what use state is because I haven't imported it. So if I hover over it, TypeScript is able to help us quick fix and import it in, right? So now I can use num-pets and use state 0, right? So let's just say that cat is a good meow and gets num-pets, right? Yeah. So let's just continue. And let's just say that we want to have a button. Let's have this outside the state tag. Let's have a button where on click, it increases num-pets by 1. Pet, then cat. Okay, so what's going on here that I messed up is basically like when I do set num-pets plus 1, it's just calling it a singular time. In order to make this a function that other people can call when it's on clicked, you would do something like arrow function so that it looks like that. And now if I get started, if I open it up, if I click this, it will increase the num-pets, right? So that's what a state is. The second thing, you can think of it more of like a member variable. That's like a really good way for people to remember it. It's a member variable and it changes the information and changes how the object itself responds. So you can think of it as like a member variable. Second thing is called a props. Props is kind of like the constructor variable. It's how the object itself is initialized. So how this component is initialized, this thing is called a component, by the way. This is called a React component. All the way to the render, right? And basically it is the constructor variable, which means it's the things that are passed in. It actually cannot be modified because it is like the constructor variables, right? So what you would like, let's just do an example of it. Okay, so where are we here? Okay. So let's just make a new React component, right? Because that's probably useful for you to know anyways. So let's just make a React component called I am cat, okay? And it returns this button because every cat should have its own like petting number, right? You're not petting all cats at the same time, right? We have the button, and what else do we need? maybe numpets should be private to a singular cat. So I'm going to copy it over there instead. And then, let's see, maybe we want a name, right? So maybe we want a name for the cat. And I think that's about it, right? We just need the name for the cat. So how you would do that is you would do props and then maybe like name string, right? But generally you wouldn't do it like this. What you would do is you would do something like generally also these are capitalized. I am cat props and cat props and then name, right? So it's easily modifiable. So you can do something like I am cat props. And then now you can make it so that like I am cat. Oh wait, no, props dot name deserves has received non-pets meow meow. So this D is called a prop, right? So it's the thing that's passed in, which is string. And how you would pass that in is imagine this div, you wanted to instead create a bunch of I am cat function components. So how you would create a component is it would look something like this. I am cat. I am cat. Oops. Let's see. And the reason why it currently is getting a little angry is because right now it is also expecting, why is it angry? Anyways, it's expecting some name is equal to some name. Cat, right? And let's take a look as to why it's so angry. I'm going to first bring this stuff up to the top. And then I'll take a quicker, deeper look into why I'm interested. Okay, so it doesn't accept any coding, so that's why I was a little angry when I tried to give it a child. So if there's no children, then you might need to just make it into one single element. So now, like if I take a look at it, you can make it so that like you can increase every single one of them, right? Which is pretty powerful. So yeah, that's how you would use state and props. So just to reiterate, state is like a member variable. React only knows when to re-render, which is recalculate everything to like show to the DOM when the state has changed through the setter of it, right? For props are the original input passed into a function. So imagine it as like the things you put into a constructor, right? It's kind of important that you know the difference between these two. So try to review this if that doesn't really make full sense. So there's another thing called class-based components, which looks kind of like this, where there's a constructor and there's a render, right? So render is the thing that's rendering, and constructor is like, oh, like this happens in the beginning, right? There's also a few other things called component did mount and component will amount, which is that like this will happen when the component mounted and this will happen when the component will amount, right? I'm just mentioning this because there is a lot of cases where like legacy code is being run, and it is useful to know like how the class-based relates with the functional components. It's basically exactly the same thing, it's just a little different, and I will go over a little bit as to why we're using functional rather than class-based. So for functional, why we're using functional, around like September last year, React released functional, right? And there's a lot of reasons why we're using functional. It's lightweight, it's easier to read because it's less code, there's nicer hooks, so like generally you like use stuff, remember the stuff up on the top so you know all of the states. As for like class-based, it's kind of like a little random sometimes. You'll see some places like it's just like a little messier, right? So hooks are a little neater. There's a slight performance boost, and there's just generally not a lot of pros for class-based. So like if you have the option, which sometimes you really don't, right? I definitely recommend defaulting to functional. You can definitely read up on more as to why functional. Let's see. Yeah, it's going to be at the bottom of this. Where it is. Introducing hooks. You can just read this if you're interested into why we're doing functional versus class-based. But basically, like as a short history lesson, functional has always been a thing. It wasn't very popular until hooks were introduced, and hooks made like functional based like a lot neater, lightweight, performance stuff like that, right? So that's why we're using functional. So yeah, that's like mainly what I wanted to cover like today. Just like mainly just to reiterate, maps. You know how like we did like functional like things like this, map and React. So that is spreading. There's the primitives for like typing. There's this, yeah. And then there's also like props and state, right? So it's good to practice this stuff, right? Because that's a lot of words, and honestly, you don't really understand something like generally unless you actually do it yourself, right? So I have a little like try it out yourself where you can specify 3 foods. So first try to specify 3 foods and try to make this tryout so that like you can add another duplicate to your list and you can remove the item from your list, right? And the learning goals of this tryout is you'll learn state, you'll learn props. Hopefully you're doing this on Git and pushing this. You can definitely like ping me and tell me to take a look at it, and I'll like give you like slight feedback. So you can practice Git. You can also practice like React keys, create React app, TypeScript, and just basic React structure, right? So if any of this is more like you're interested in and want to read, here's some more resources that I've like covered slightly throughout this like short like session. So yeah, like that's mainly what I wanted to cover all of today. Just JavaScript, TypeScript, functional programming, listing keys in React, state and props, and why functional React is better, right? I highly recommend doing a little tryout just because, like I said, just to reiterate, practicing is good. So yeah, that's mainly what I wanted to cover. For the next session, I'm just gonna probably go over a little bit more as to like how to think about the React structure of things. And then we're just gonna do a little like walkthrough, like a little like do it together, where we're gonna make like a little like to-do list. And that's basically all we're gonna cover. And then that's going to be like the end of React, like solid React. After you have these three sessions out, so the first one from last time about like the environment, this one about React states and props, and then the next one for like React, like thinking in React, you'll have React down, but we'll have a little bit more sessions to have a little bit more advanced React. So yeah, thank you for listening, and hope that made sense. Bye-bye.